we will talk about the same equations, but now we will talk in a vertical direction if the object free fall. These equations used if the object move in a straight line, okay, and horizontally, so you can calculate the acceleration. But if the object moves downward, then the acceleration equal acceleration of a free fall, which is 9.81 meters per second squared on the earth. So we will talk about free fall. If the object fallen freely from a height, so its initial speed is 0, its acceleration is acceleration of a free fall. You can find the value of acceleration of a free fall for any planet using the equation S equal ut plus half a t squared. Let's see how can I use this equation to find the value of acceleration of a free fall of any planet. S equal ut plus half a t squared. Initial speed equals 0. So this part is also 0. S is the height, which can be measured using a meter rule. Now, I have to take the distance from the bottom of the ball till the bottom of the ball when the ball hits the floor. Here the velocity of the ball is very high and it's unknown. I can find it as well. Now, h, which is the height, depending on the ruler or meter rule, depending on the height, it's equal to half multiplying by the acceleration of a free fall times the time. Using stopwatch, you can find this time multiplied by t squared. Okay? So it's very easy to calculate the height. But you know that there are many errors in this experiment between reaction time in starting the stopwatch and measuring the height if there is a wind. If I take the place without wind, but the reaction time still acting, to decrease the reaction time, you can do the experiment many times by using different heights in meter. So you find the time in seconds and then find the square of time in seconds squared. So you can take many values of height and time and t squared as well. And if you draw the relation between height in meter and y-axis against time squared per second squared, you will have a straight line passing through the origin. The gradient of this line is very important. What is the gradient of this line? We know that h equal half multiplied by acceleration of free fall times t squared. Okay? This equation is the same as y equals mx because we put the time squared on the x-axis. So the gradient of this line equal acceleration of a free fall multiplied by 2. So if you multiply the gradient by 2, easily you can find the value of the acceleration of a free fall in a good way with a good value. Also, you can calculate the final speed here using v equals u plus acceleration of a free fall multiplied by time. This is time. Acceleration of a free fall is constant. U equals 0 because the object released from rest. Okay, and you can use this equation as well. All the time, what you have to do, you just put the acceleration of a free fall instead of acceleration in the moving of the object in vertical direction. Now, if the object moving downward, then the acceleration of a free fall is positive 9.81 meters per second squared. If you take the object and you give the object an initial speed to moving upward, so the acceleration of the object, it will equal to negative of the gravity, which is negative 9.81 meters per second squared. Why? Because the speed of the object decreases gradually, and the gradient of speed time graph is the acceleration. Here we have the velocity time graph. Okay, here the acceleration of the object, and again here's the acceleration of the object. Here's the positive acceleration, and here the negative acceleration. And here the displacement, it is the area under the curve. And here we have positive area, so positive distance, and negative area. If you want to find the total displacements, you calculate these. If this axis is not acceleration, if this is velocity, if this axis is acceleration, it's not the same. Let's see what happened. If we have displacement time graph, the gradient of displacement time graph is velocity, and the gradient of velocity time graph is acceleration. The area of velocity time graph is displacement, and the area of the acceleration time graph is the velocity. So you can calculate whatever you want by depending on the figure, depending on the axes. Is it with time or with acceleration or with speed? Now, the past examples was talking about objects moving in one dimension, horizontally or vertically. What happens if the motion is in two dimensions? Okay, this is what we call it a projectile motion. You push the object like this, and the object will move in this motion. Okay, you may push the object like this from the top of a cliff, and the object moves in this way. So we have two-dimension motion. Okay, we have a motion in the x-axis, and we have a motion in the y-axis. So we have to be careful in treating these questions. Now, let's start by pushing the object horizontally from the top of a cliff. If we have initial speed here, okay, and the object starts moving this way downward, what we have velocity in the horizontal direction. This is the horizontal speed, Vx. Here the speed in the y-axis equal 0, but the speed in the x-axis is v. The speed acting on the x-axis will not change, okay? Speed acting on x-axis is constant. Why it is constant? Because acceleration of a free fall will not affect the horizontal motion, okay? But you can find that the speed on the y-axis, it starts 0 here, then the speed on the y-axis will increase directly. So we have an increase in speed of y-axis. Again, we have a cliff with object moving like this. This is the horizontal speed, which is constant, okay? And we have vertical speed, which increase as the object moves down. So you can have two directions, a horizontal direction and a vertical direction. And using the equations of motion, you write here S, U, V, A, and T, which is the Sauvage equations, which are V equals U plus AT and blah, 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 as we mentioned before. You can see that the speed on the x-axis and the speed on at the initial point and at the final point have the same value. Let's say the speed is 30, so here the speed and here have the same value. The acceleration on the x-axis is 0 because the object have a constant speed. The distance traveled on the x-axis is the range. This is unknown. Okay? Now, the time taken for the object to move from this point to this point horizontally is the same time taken for the object to reach here vertically. So this time equal to this time. So if you know the time vertically or horizontally, it's the same. Acceleration of a free fall vertically, it is 9.81 meters per second squared. The initial speed vertically is 0. The final speed here, it's given, or you can calculate it. And the distance traveled vertically, it is the height. Okay? Using this plan, you can solve any question in two-dimension motion. Let's see this example. We have object here pushed by initial speed of 15 meters per second from a height of 45 meters per second. Okay? Then we have object here by initial speed of 15 meters per second pushed from a height of 45 meters. Make the table at the beginning horizontal, vertical. S, U, V, A, and T, 0, 9.81. Initial speed on x-axis is 15 and the final speed on the x-axis as well is 15. Initial speed on the vertical axis is 0. Final speed is unknown. The horizontal distance traveled is unknown. The vertical distance traveled is 45. The time taken is the same through x and y axis. Back to our question again. A stone is thrown from the top of a vertical cliff 45-meter height above a level ground with an initial velocity of 15 meters per second in horizontal direction. How long does it take to reach the ground? So we asked to find the time. How far from the base of the cliff when it reaches the ground? So we asked to find this distance on the x-axis. Okay? Now, let's try to find the time and the distance. Let's start by this equation. S equal ut plus half at squared. The initial speed vertically is 0, so this part is 0. The distance vertically is 45 meters plus half. Acceleration of a free fall is 9.81 multiplied by t squared. So 45 equal 9.81 over 2 multiplied by t squared. 45 times 2 over 9.81 is equal to t squared. T squared is about 9 meters per second, 9 seconds, squared. So the time is the square root of 9, which is about 3 seconds. So this is the time horizontally and vertically. Now, you can find the distance traveled horizontally. How? Horizontally, since the acceleration is constant and speed is constant, you can use speed equals distance over time. Distance equals the speed multiplied by time. Speed horizontally is 15. Time is about 3 meters per second. So the distance horizontally 45 meters. Okay, so I find the value of the distance. What about the velocity here? The final velocity reached by the object to the floor. I can use another equation, which is v equals u plus at. Vertically, the initial speed is 0, acceleration is 9.81, time taken is 3, so the speed is about 30 meters per second. What if the question asked you to find the velocity here? Okay, the velocity here. You have a horizontal speed which is 15 meters per second, and you have a vertical speed which is 30 meters per second. So to find the value of the resultant velocity, it's equal to speed on the x-axis squared plus speed on the y-axis squared under the square root. In this way, you can find the value of velocity. And to find the direction, what you need is to find this angle. To find this angle, you can use tan inverse the velocity on the y-axis divided by the velocity on the x-axis. And using your calculator, you can find the value. So we use equations of motion on the y-axis and use the speed equals distance over time on the x-axis, and we use the vector quantities and vector notation to solve for the other particles. Okay? It's very easy if you follow the rules to solve the questions. What happens if I have a two-dimension like this? I push the object from the floor and it's back to the same point. Okay, let's take a question 3.24. Okay, a football is kicked on a level ground at a velocity of 15 meters per second at an angle of 30. So two dimension, this is the ball kicked like this. Okay, the object kicked by a speed of 15 meters per second by an angle of 30. So here the speed is 15 meters per second by an angle of 30 degree to the horizontal. How far away is the first bounce? So you ask to find this distance only. Okay. Starting the same way, horizontal, vertical, so that horizontally acceleration is 0. Horizontal speed and vertical speed unknown. Why? Because the speed is given with an angle. So what you have to do, you have to find the speed on the x-axis, which is v cosine 30, and vy, which is v sine 30. Okay, sine 30 is 1/2, cosine 30 is 0.87, multiplied by 15, multiplied by 15. Here the speed is 7.5. Here the speed 15 multiplied by 0.87. Let's try to find its value exactly. One second. Okay, 15 multiplied by 0.87 is equal 13.05, let's say 13 meters per second. So the horizontal speed is 13. Okay, the horizontal speed is constant through all the motion. The vertical speed initially is 7.5. Okay, the final speed here at the maximum speed, a maximum height, is 0. If you ask to find for this point, the maximum speed is 0. Okay, the horizontal distance from here to here, it is the range, it is unknown. The vertical height is unknown also. Acceleration vertically, it is 9.81. The time is the same and it is unknown. So you may be asked to find this height, or to find this distance, or to find the speed here. Many things, okay? Let's start to calculate this height. Let's say to find this height. Okay. S equal ut plus half at squared. It's not good to use it because we don't know the value of the time. Okay? Maybe if we use v squared equal u squared plus 2as, it is a good way. The final speed at the upper point is 0. The initial speed vertically is 7.5 squared plus 2. Acceleration moving up, it is negative 9.81 multiplied by s. Okay, take this to the other part and you can find the value of the height very easily. Here you will have a negative sign, but the negative sign will be deleted with this negative. Why this value was negative? Because the object moving upward and the acceleration is decreases. Okay? Now, if you ask to find all of this distance traveled, okay, you have to find the time at the beginning. So, I can find the time while the object moving up and multiply it by 2, because the time taken for the object to moving upward equal the time taken for the object to moving downward, because the system is symmetry. So v equals u plus at. We have the final speed 0, initial speed vertically 7.5 plus negative 9.81 multiplied by time. In this way, I can find the value of the time moving upward multiplied by 2, so you can find the total time. After you know the total time, speed horizontally equals distance over time. Speed horizontally known, time is known, so you can find the distance. There is another way which is easier than this to find the distance or the range traveled. You just use this equation, r, which is the range, equal u squared. U, it is the initial speed of the object at the beginning, which is 15 meters per second. Okay, so 15 squared sine 2 theta, the angle is 30. Okay, multiplied by 2, it is 60 over 9.81. This is an easier way to find the range without taking the component or anything else. So depending on the question, you can choose the best way. In paper 1 questions, the multiple choice questions, I think it's easier to use the equation to find the value of the range without taking the component. Here we have the equations of motion, which is known before, and we can use the acceleration of a free fall if the object moving vertically. Now, if the object moves like this, let's have a new paper, new page, like this. The object moves from here to here, and I want to find the total time traveled by the object, I can use s equal ut plus half at squared. Since the object back to its original place, okay, so the vertical displacement of this object is 0. So we have 0. We have initial speed vertically, which is 7.5 t, depending on the last question, plus half acceleration of a free fall, since the object back going up and back. Here the object moving up only, we put the gravity negative. If the object moving down only, we put acceleration of free fall positive. But if we take all the motion, we use acceleration of free fall in a negative sign. So negative 9.81 multiplied by t squared. Take this to the other side. 7.5 t equals 9.81 over 2 t squared. We have negative sign from here and negative sign from gravity. You can delete these together and t with squared. So time equal 7.5 multiplied by 2 over 9.81. In this way, I can find the value of the total time of the object if it's back to its original value or original place. What if the object moves from here and it's not back to its original place? Okay, so I can use this relation also after I take horizontal and vertical, but when I want to put the value of s, I will put its value by negative sign. Why? Because if the object moving up, the displacement is positive. Here the displacement, when you back to original place or parallel to the original place, the displacement is 0. When you moving down, the displacement start to be negative according to this reference. Please try to solve more questions from the book and from the past papers to have a good knowledge about this subject. Thank you for today and good luck. Assalamu alaikum wa rahmatullahi wa barakatuh.